We welcome you once again on behalf of the Mechanical Engineering Department and Universal Engineering College.
Thank you, madam. Thank you, sir. Thank you for this wonderful introduction. It's a privilege to be here, to be talking to you, all of you, and to be introducing to you the concepts of project management and contracts administration. So I would like to know how good are you able to view my screen? Going to the full screen mode.
Yes, okay.
Is
I
this,
cannot see your presentation so far.
you can't see my presentation. Okay. What about now?
Yes, it's just loading. Yeah.
Okay,
Okay, yes.
we'll start.
Okay.
Yeah, it is now visible. Yeah.
Okay, great. So, yeah. So, what I would say before going into the details of this topics is there. One second, the slides. Yeah. I really want to express my gratitude for this opportunity given to me. See, it is an opportunity for me as a professional as such because it gets into it gives me a chance to interact with people, to share my knowledge, and most importantly, when I'm preparing for such a presentation, it gives me a chance to look into the blind spots within my own experience and my own technical know-how. So while I'm preparing, I must really admit, while I was preparing for this presentation, I did learn a lot of things which I thought wasn't so important, because the whole point of this presentation was to compress a lot of data, a lot of knowledge into a span of 1.5 hours. And I really must admit, this it's impossible to teach you the full span and width of project management, either project management or contracts administration, in this time, because it's a huge area. It's the vastness of the scope is much more than you can really fathom at this point. See, normally contracts administration is said to be an industry within an industry, because you see, civil engineer or construction as such is an industry. Construction contracts administration is a very complex procedure that is embedded within this whole industry. So you have to have special set of knowledge, special skill set to be practicing with contracts. But yes, my priority or our priority at this point is to know where everyone stands here as a student, and how you can step into the worlds of project management and contracts administration. Okay. Now, there is a lot of things, there are a lot of things omitted on purpose, because to compress, I was trying to prioritize what would be most important for you, what would be most beneficial for you, if I'm to be mentioned within the span of 90 minutes. Okay. And of course, there are some definitions. There is a lot of data, and I have tweaked them to be made more presentable. When you start studying things, you might find it a little bit different from what I mentioned here, but that's okay. It is not going to stop you from functioning with, you'll basically get all the building blocks to start functioning or start uh, learning stuff. Okay, I don't expect you to be a project management professional or contracts administration professional right after I finish the presentation. What is expected out of the presentation is you learn stuff, you understand what is the process, and you have a picture, you have a macroscopic or a macroscopic view of what is happening, and then you start building on things one by one. And yes, of course, again, I have explained things in a non-linear fashion. I tried to maintain the linearity as much as possible, but it is still non-linear. It goes back and forth. But in the end of in the end of the session, I hope you can see everything falls in place just like a jigsaw puzzle. And yes, since I'm a planning engineer, this whole session is from a planning engineer's perspective. You see, there are different perspectives to the project. A planning engineer's perspective is different from a commercial engineer's or quantity service perspective. That is different from a quality control engineer's perspective. That is different from a resident engineer's perspective. That is different from a project manager's perspective. Now, starting from the project management perspective at this point is not so beneficial, because my understanding is, if you understand the whole process as such in a simple format, if you finish, if you get one full pass through the whole process, and then you will be able to assimilate the data later on. It's just like functioning with Google Maps. You see, when you use Google Maps, you have all sort of indications, the directions, the time calculations, and stuff, right? So before the detailed calculations are displayed, it'll show you the route, and you can select the route at which you can reach the destination. Okay, so you can tell this process is meant to show you different routes. That's it. And yes, as I mentioned before, the take home for you today as students is a perspective on how to work your way upwards in this industry. And then the interrelations. See, project management and contracts management, contracts administration are two different streams which are related, which coalesce, which interface at a lot of points, but they are different. Okay, but their interrelations, understanding the interrelations is very beneficial to get into the subject, and to understand the subject, to learn the subject. And finally, of course, a lot of practical ideas. That is the, what is that? Uh, if you're seeing Apple presentations, they'll be showing one last thing. Yeah, this is the one last thing for you, which I've kept at the end of the session. Okay, so before we start, I'm going to request you to forget your respective trades for the time being. You see, now this might come as a bit painful for you, because uh, while being in college, all the students, it's, even I've done that. We wear a department like a suit of armor, like a badge, like a suit of armor, because we want to be represented as a civil engineer, or we want to project ourselves as a civil engineer or mechanical engineer into the world. But what we forget is we have to be an engineer first. Now, the common mistake that happens when we get stuck with that idea of being an engineer of a particular trade is it weighs us down. It totally weighs us down to an extent that we miss out on a lot of opportunities. You see, if I'm just being a civil engineer, I'm just focused on the civil engineering aspect of a project, and I'm totally ignoring what is the project as a whole. Then yeah, I'll be trying to specialize on my civil engineering knowledge and stuff. But what happens is, you see, in the grand scheme of things, you'll become a specialist, but you will not be able to interact with the team. And unless you know where to stand in the project, you're useless. You can get a degree, you can get a master's degree in civil engineering, but how to use it is the most important question we all have to start asking ourselves. Your trade is just a choice of a weapon. It's like if you compare life to a battleground. Your trade is just a weapon, whether you use a sword or whether you use a bow and arrow. It really doesn't matter. If you're a master of it, if you can masterfully use it according to the situation, well and good. But it's better if you can use one or two weapons, because suppose you lose one thing and you have a basic understanding of another kind of weapon, you can use that in the battlefield. And I'll tell you, project is a real war front. So today, you're just an engineer evaluating your options ahead. You are not a mechanical engineer. You're not a civil engineer. You're not an engineer from any form of trade. See, because project management applies not just to civil or mechanical engineering streams. Project management applies to all stream of projects, be it electrical, mechanical, computer science. If there is a project, you can apply project management knowledge and ideas. So today's topic will have two different parts. One, as said before, project management and contract administration. We'll go ahead with the project management first. Now, what is project management? I'm going to skip what the definition of what is a project, uh, because I'll tell you later. We'll start with we can't go start from that scratch of a thing. We have to start somewhere. So we'll I hope you can see this. Yeah. So project management is the application of knowledge, skills, tools, and techniques to project activities to meet the project requirements. Okay, so that is the theory part. Now, why did I quote Project Management Institute? Project Management Institute is a non-profitable organization that has studied projects from all through the entire spectrum of engineering. Okay, and not just engineering. If you have an activity that has, if you have a process that has a start and finish point, and that requires time, that requires effort, that can be classified as a project. This is not a definition. This is just to give you an understanding. So, Project Management Institute has studied projects from all walks of life. Okay, be it from building a small house to multi-billion-dollar intercontinental ballistic missile programs, or launching rockets, satellites into the outer atmosphere. They're all projects. Okay, sometimes project gets too big that they get classified as programs. Okay, but again, the whole point is, having studied all these projects through the entire spectrum of engineering, you get an idea about how to start, how to manage, how the process develops, and how to complete it successfully. And that is the intention of this institute. And now, PMI, I really suggest you guys have a look into the website of PMI, because they provide a lot of certifications. And as a student, it is best if you can get a CAPM, which is Certified Associate in Project Management. Now, the advantage of that is, if you see, you come right after you finish engineering, you finish an academic program, but how does a project management happens in real life? And if you're getting certified from an institute like that, the advantage is you get a clear picture of what things are, and there is a professional body certifying your knowledge on this. Just like you get an engineering degree, you get a specific professional degree. It's not a degree, professional certification that can be highlighted in your CV, so that see, so that people know that you have some basic fundamental know-how of how projects are and how projects are supposed to happen. Now, before going to details of project, again, I would like to highlight the advantages of being a project manager. You see, or let's say, yeah, the benefits and perks, the kind of salary expectations. See, basically, I talk from the AEC industry right now. AEC stands for Architecture, Engineering, and Construction. Mechanical engineering guys, don't feel bad, because mechanical is a part of this AEC industry at not many points. But this industry as such, mostly, if I'll be talking about civil engineering projects like building construction, hospital construction, and stuff. But there is a mechanical engineer, a mechanical project manager from a subcontractor. That will be the MEP subcontractor in the major civil engineering project coming up. So don't worry about that. And then I'll be comparing with EPC. See, I've also worked in the oil and gas sector, so I know how project happens in the EPC environment, right? So, but predominantly this discussion will be based on AEC. Just giving a heads up. The benefits and perks, salary expectations can be something upwards of 30,000 dirhams a month, which is roughly 6 lakh rupees. Okay. And the perks, there are a lot of perks. We can discuss that on a later front. But one thing I would like to highlight is, you see, when you're a project manager, you are the expert, you are the decision-making authority in that project. You're the license officer. So if a material has to be inspected, suppose let's speak about oil and gas industry in this context. Suppose you're building a pressure reduction skid, or let's say, yeah, skid, or your manufacturer, there's a valve that has to be installed in your pipeline, right? So this valve, uh, as per the client, there will be a list of contractors, there will be a list of valves that would be applicable to that project. That's called pre-qualification. So you have to select a supplier who has been pre-qualified, and this valve would be manufactured somewhere else across the globe. It could be Italy, it could be Germany, it could be UK. You don't know. Only when the project happens, you decide where to get that valve. Okay. Now, as a project manager, you have to go and inspect this valve. You can send a quality personnel, not a problem, but the responsibility is still of the project manager. Project manager sends a person in his stead to go and inspect the valve. Now, you get an opportunity to go out of station and inspect the valve at the uh, let's say at the expense of your own company. Okay, so that is something which I really want to highlight. You can't normally, when you think of a project, you think that people are confined to an area, a region, a country. No, if you're a project manager, you will get chances to travel across the world. Now, this should come as a real perk. Salary part, you can leave it. See, basically, manager, if in this part of the world, if there is a designation as manager, your salary will be upwards of 30,000 dirhams, which is close to 6 lakhs rupees, I mentioned. And there's a spectrum that is loosely followed. If your entry level is as an engineer is 2,500 to 3,000 dirhams to 10, and then a normal engineer is 10 to 20. I'm speaking in dirhams, of course, 10 to 20,000 dirhams. Okay, and a senior engineer is like 20 to 30,000 dirhams. That is a scale that has been followed. So project manager starts at 30, and there is no upper limit normally. I mean, yeah, of course there is a limit. You cannot be more than senior management. But you see, it all depends on your ability to negotiate your company, and also your ability to bring about value in that project. If the total project value is only 2 million or 3 million dirhams, you cannot definitely ask for 100,000 dirhams a month. Okay, so let's keep that bracket between 30,000 dirhams to 60,000 dirhams. 60,000 dirhams is 12 lakh rupees, roughly 12 lakh rupees a month. Now, the qualifications. Now, this is the really important thing. You see, qualification wise, if you have a degree, you can start as an engineer here in this part of the world. But the most important qualification you need is a PhD in smartness. There is no denying that. You need to have a PhD in smartness. You mean you need to be at that level of smart. You have to control the project in such a manner that it brings about the best of the results. Everyone looks up to you for suggestions, directions, for solutions, answers. You will have a lot to face as a project manager, but you start small, and it takes normally 10 to 15 years to reach to the level of a project manager. If you're really smart, super duper smart, you can be a project manager at 8 or 10 years of experience. But you have to have that good an experience, that good a CV, and you have to land in such a good project right from the start. Okay. Otherwise, it takes at least 2 to 3 years figuring out how things happen in a project. Now, this kind of sessions, how helps you is, it gives you an idea how things are supposed to happen. So it flattens that learning curve a lot. Okay, and qualification. Otherwise, of course, it is always an added advantage to have professional certifications like a membership and Chartered Institute of Building, and a PMP. Of course, PMP is provided by the Project Management Institute. That definitely adds a lot of knowledge, value to the knowledge you have. But it all depends on how you utilize it. Okay, so a degree, a master's degree is not much of a use as long as you don't know how to use it. And that is specifically talks comes into play when you're a contractor. But yes, of course, if it's a specialist area of expertise, specialist area which you're working, then um, being having some specialist master's degree helps. Okay, and but when you're consultant now, this three category of people that they make up the entire project, major chunk of the project. Then of course you got subcontractors, end users and stuff. But in a contract, these are the three people coming into play. Now you start off as a contractor, then you become a consultant when you have enough experience, and then finally you become you work at the client level. Now, of course, there will be exceptions. You can start with the consultant level if you have the sufficient knowledge, sufficient expertise. Not a problem with that. You can even start as direct as a consultant. But normally, this is how the career progresses. You start as a contractor, become a consultant, and client. But yes, of course, the pay in contractor is more. You become definitely more. There are many reasons, but we'll keep that discussion to a later point. And skills, yes, the skill set required to become a project manager, you have to be a jack of all trades. That is what I meant by JOAT. Pardon me, that's a made up name, but that serves a purpose. You have to be a jack of all trades. You need to know everything. Now you'll come to see that in the later slide. Interpersonal skills, how you deal with people, paramount. Negotiation skills, you cannot survive without negotiation skills. And finally, it all all the skills are project dependent, because if it's a small project where your technical knowledge is required more, then you can compromise a lot on this. But most of the projects, what I'm saying, I'm speaking about projects like having an entire township being developed, or a mixed use development that is worth 1 billion dirhams, which I work right now, which I'm working right now. 1 billion dirhams, which is like 20,000 rupees, 20,000 crore rupees. Okay, so that kind of a project, you cannot manage everything without these skills as a basic minimum. Now, this slide, in this slide, we are getting directly into the project. Okay, now as per PMI, you have, whoa, 1 second. Okay, there, this is how a project normally develops. We have 5 process groups, okay, and 10 knowledge areas. 5 process groups simply means the 5 phases of development of a project. Okay, you have an initiation phase, then you have planning and design phase, and as the arrow indicates, initiation starts everything. The project managers are brought into the project, and there are project charters being developed, and the project manager budgeting. Sorry, that comes in planning and design. Sorry. So that is, you start with the project from a business case. Okay, so that is the initiation part. Now, business case means, suppose you have an area. Oh, by the way, I have actually prepared a sample project for you, which we'll see in the later slides. You have a big area where you don't have any hospitals. Okay, so you represent a company which decides that, okay, if we build a hospital here, specialty hospital here, then we could actually gain a lot of money from it. There'll be a lot of benefit financially, and that will be a big, but much better than that, there'll be a big service to the people there, because people don't have to travel a lot, long distances to go to the hospital. So that is the business case. That's a viable business case. So from that business case, initiates the project. Okay. So initiation gives to planning and design. That names explains it all. Let's not go into much details here. Just understand the name here, planning and design. From planning and design, once the planning and design is completed, we go into execution. Okay. Now there's an arrow here that indicates it goes into execution. But there is a backward arrow here which indicates that from the execution, something is fed back into planning design. And that is nothing but reports. Now, these arrows here, see, from execution, there are reports and data that is fed into a planning stage and monitoring and control stage, which follows the execution stage. Now, this indicates there is data transfer. Now, monitoring and control decides if whether the project is as per the plan or not. Okay, so there's a communication between these two. There's a communication between these two. Okay, and just to check whether you are on track or not. On track based on a lot of parameters: time, cost, quality, excuse me, expectations, stakeholder expectations, stuff. And finally, once all the project parameters are satisfied, okay, preset project parameters are satisfied, then you go for closing a project. So that is how a project develops. Now, what you see here is an expansion in that into a matrix. These are the 5 phases of development of a project. Now, this is taken directly from a PMI's what is that material, because this gives an idea about how you should start, or what are the minimum things you should understand to start functioning in a project in a responsible position. Okay, so 5 phases of project development and the 10 knowledge areas, essential, inevitable knowledge areas. You need to know how a project starts. That's what meant by the integration management. How the project starts and how the things are supposed to be, how in what direction things are supposed to start. That is integration management. How you integrate different components together. Okay, but just before that, let me just talk about this graph here. Okay, so I think you're familiar with the color coding here. Now this is the time axis. This is the effort required. Now the first initiating part, we start from 0. Okay, that is again integration management. Initiation, and then peaks at a point and then goes down to an asymptotic level, or sometimes even 0. The effort required in its initiation is the most in the beginning, and slowly after that, planning takes over, and then the full effort is on planning and design. Okay, and soon after planning and design, monitoring and controlling takes over. See, but monitoring and controlling is not as active as a planning process, because you have a time to plan for, you have cost to plan for, you have quality to plan for, you have communications to plan for. Planning, you just look at this. See, planning has the maximum effort in this matrix. Planning and design. Sorry about that. And then execution starts from somewhere here. Execution has the maximum effort. No matter how much effort you put in planning, unless you execute, there is nothing happening in the project. So you start execution, and then there's a lot of effort in executing the project. Okay, and then finally the closing part, which happens after the planning and design comes to a halt. And through the whole process, we have monitoring and controlling. Okay, so that's how a project develops. And with this metrics, I can explain it still further. You have 10 areas where you have to have specific knowledge. Scope, how do you manage the scope of the project? What is to be done in the project, and how do you plan to manage that? How do you plan to execute that scope? Okay, and then schedule management means how do you plan for the time factor within the project. Cost management, you see there is a cost element involved to the project, and how do you manage the project in such a way that it doesn't overrun the cost allocations. And then quality, what are the quality metrics? How do you say that the project is complete, or different phases of project is complete, and what are the expectations of each phase? That is quality. And resource management, basically the team involved within the project. How do you build a team? How do you acquire a team? How do you build a team? How do you manage them? See, these are the things a project manager should know to run a project. Okay, and then resource management, communications management. What are the different kind of information that goes up and down within a project? What is the basic information required for a person, and what is the mode in which it should be transmitted? Because sometimes official data cannot be transmitted through phone calls or WhatsApp messages. you have to write a proper letter, okay, so that things are clear on both sides and there is a record, right? But some people just require verbal updates. So who are those people? Now that is managed in stakeholder management. What are the people? What are the expectations? And based on that, you assess their communication requirements, data requirements, and you plan for communications management. Risk management, what, see, a project could go wrong in n number of ways, right from the even before you start. So once you have this the project schedule and project cost values and all, you plan the risk into, you assess the risk conditions of each activity, and then you plan risk responses and mitigation measures. Sometimes if you cannot avoid, you plan for mitigation measures. Sometimes if you can avoid, you plan for the risk, and when you reach that point, you do that particular activity of risk management. Now this is all theory. We'll get into the practical part later on. Just bear with me. Procurement management, how things, see, contracts management comes actually as part of procurement management. How to start things, how to close. That's it. Now, for our sake of discussion, I would be using this table. Okay, this is how normally a project develops. This is the start point, and this is the finish point. Now, especially in the AEC industry, this is how the project develops. First, a client has a requirement at this point, right? And discusses that with architects and designers, and comes up with a concept design. Now, once the concept design is approved, a detailed design development happens. Okay, and this point, once a detailed design is finalized, it's approved, then the construction phase starts. Now, construction phase, uh, and then we have the closeout period. Okay, as you can see, this is the 5 process groups listed out just for the sake of comparison. Monitoring and controlling is part of implementation. Now, yeah, with the next slide, you'll be able to understand it more about the difference between AEC and EPC. This is the AEC industry. You see, there are different people involved within a project, as I mentioned earlier. Now, 3 most important people coming within the project are the employer, the engineer, the contractor. Now, why did I emphasize on that? The, see, this has got the letter the has got the word the has got a significance, because when you add the to an employer, it becomes a contractually defined item, contractually defined party. A contractually it has got a contractual definition. So the employer means a party coming into contract with the contractor. Okay, so when you mention the contractor, there is only one contractor, the contractually obliged party. The employer, the contractually obliged party. Now there are rules and responsibilities assigned to this person. It's like a tag, okay? And there are rules and responsibilities assigned to the contractor, and these 2 people come into contract. Now the engineer is also part of the contract in a different way. You'll see that later. So now the engineer is actually a broad term because this consists. Now, engineer, when I say engineer, the there are consultancies, engineering consultancies that provide services, a lot of services, design, then supervision, project management. Okay, so in the project, the role of the engineer is to see that the project is as per the contract. See, in one word, the engineer is the referee between these 2 people. I shouldn't be saying this, but just for the sake of understanding, when a referee of the match of the whole project, the engineer, right? Okay, the contractor comes into play at this point where the development phase is over. Now, because at this point, the construction contract is provided to the contractor, or the employer enters into a construction contract at this point. You see this yellow line. At this point, the employer enters into a consultancy contract with the engineer. That is the difference between these 2. Okay. Now, when we talk about construction or contracts management as such, what is to be kept in mind is the contract between the employer and the contractor and the construction contract, because a consultancy contract is not that much of a significance at this point. But yes, from the project management perspective and the BIM, building information modeling perspective, yes, it is. Okay, but we'll be discussing more on the the contract that enters, the contract that between the employer and the contractor. Now, there is a difference between AEC industry and the oil and gas industry. You see, the process is still the same, but the architecture development that happened in the AEC industry is is called feed, front-end engineering design, in the EPC environment, and you have feed consultants. Okay, so what the architect did here, architect and the designers did here, the feed consultants do here. Okay, and then uh, in EPC environment, in the oil and gas, EPC means engineering, procurement, construction. Okay, oil and gas projects are normally called EPC projects. So in the EPC environment, you normally FIDIC projects are not used in my experience. There are definitely FIDIC contract forms that applies, but since the governments and government bodies are involved, they prefer to use bespoke or custom contracts. So these terms, the client or the engineer, sorry, the employer, the engineer, the contractor words doesn't apply here, right? Okay, so we'll start with the concept design and detailed design. Um, I'll show you the, what is it? One second. Okay, I'll show you the chart, what is organization chart of our sample organization chart, which we have in my company, just to give you a feel of how the concept design happens. Concept design and detailed design. Okay, so a project, now we mentioned that suppose you want to construct a hospital. Now the project director and the planning and coordinations manager have holds discussions with the client to understand the client requirements, right? Now from the client requirements, they list out the client requirements. What is the budget, what are the facilities to be provided, how do we what is the facilities that are always there, the plot, the size of the plot, what are the amenities that the client can afford, all the stuff. So a lot of discussions happen to finalize the requirements of the project. Okay, and this requirements is fed into the company atmosphere, that is the architectural department, structural department, MEP department, medical engineering team, and the interior design team. And they initially come up with a concept that they believe is feasible. Now this, they can have actually a lot of concepts just to give the employer or the client a lot of options. Okay, but finally this process is not a long one. This is only to check what is the optimum solution as per the client requirements, right? Now after the concept stage starts the detailed design development. Now in this detailed design development, uh, the architectural team takes the approved concept design, okay, and they develop the detailed architecture of the building, the complete look and feel of the building, of the structure, whatever it is, hospital. Now, once they have done with the architectural part, they hand it over to the MEP team. Sorry, my mistake. They hand it over to the structural team to check for the structural viability of the of the architecture, and then this structural team hands it over to the MEP team, right? The MEP team designs for the mechanical and electrical components of the project, the HVAC system, uh, and what is it? All the electrical components, the power requirements, all the load calculations. They do it, and they have their design, and then they hand it to the medical engineering team, and medical engineering team hands it over the interior team, and it goes in a loop. Okay. Now, by a loop, what I mean is after the architectural team hands it over to structural team checks for structural integrity of the design, and then comes up with a lot of comments, like suggestions to improve, to or to change, say that okay, this is not as per the regulations, authority regulations, this will not get approved, this has to be changed. So there is a stage which is called IDC, interdisciplinary check. Okay. And this comments is forwarded back to architectural team, and then they complete the what is it they finish the comments, or they revise the project, revise the data as per the comments, sends it back to the structural team. The structural team and then does the same project, the same process with the MEP, medical engineering, interior, and finally they all come to an agreement which becomes the final design. Now, this final design is sent for authority approvals, because you cannot construct a project just by that. You need authority approvals to start with all the processes at site. Now, the people in this team are well aware of what are the authority requirements. So it is not just technical know-how. They need to know the law that prevails in designing each and every component. And these people will also be approved by most of the people, especially structural MEP people will be approved by the, ideally they should be approved by the authorities, so that authorities know. They give an examination in this concerning with the concerning authority, and then once it's clear, the authorities know that okay, they have some minimum understanding of the rules and regulations, they are fit to start designing. Now, our role is not in designing. Our scope of discussions today is about project management. Now, the project management team is a bit different from the design team. You see, we had a structural design team here, but when it comes to project management, we have a civil supervision department, and the most senior person of the civil supervision department is called a resident engineer. Right. Otherwise, the person in the architectural department is called resident architect. This I'm talking from the consultant point of view. So this is the team that manages the project right from the contract is signed. Okay, so this is the supervision consultant team. You have a mechanical engineering team, you have a commercial contracts team, planning team, and documentation department. Now, what these people do is, you see, they verify the work at site. If the work done at site is as per the initial design or not. Now, just to give you a feel of the contractors team, I have included an organization chart of the contractor. Now, this is a project manager of the contractor, and this is his whole team. This is a sample representation. Project manager will have a very strong construction team comprising of construction managers, site engineers, project engineers, yeah. And then you have, commercial department. See, these gray colored items are all, what is it, corporate level, corporate level teams. And this is a blue color is a project team. So there will be a corporate level supporting the project manager, and they'll be sending their people to, let's say, support the project manager. You have a QS coming from the commercial team. You have a QA/QC, quality control, quality assessment, quality control engineer from the quality department, cost control engineer, safety engineer, planning engineer, coordinations engineer, design team, etc. Now, the role of each engineer, see, quality, commercial part, sorry, we'll start with the commercial part. They check if the project is billed on time. The work done is approved, and then that approval can be converted into money, monetary terms. They are in what is it? They are in charge of the billing of the project. Okay, how they invoice the project from the contractor's side. Quality department. Now, the quality department, they propose in the initial phase of the project, they propose the quality standards that will be complied to within the project. So they have to prepare a project quality management plan, and then they also prepare all the method statements Um, but yeah, that is shared between quality department and the project engineer. But they make sure that the project is as per the required quality specifications of the project. Okay, and then you have this contractor is particularly smart because he has a separate cost control department. Now there are engineers just to control cost of the project. What happens is there's a commercial team here, quantity list of quantity surveys under the commercial department, but their priority will be to bill invoice as per the progress. Now there is a person here sitting just to see, just for cost savings, just to optimize the expenditure within the project from the contractor side. Okay, and then you have a safety engineer, a very important role, because safety engineer makes sure that whatever is done at the site and in the whatever done uh, at site and also the laydown area, or the project office area is safe. Okay, so all the activities, safety, this person is responsible for the safety of the entire project, right? So he has to devise plans so that people are safe, there are no accidents, there is no LTIs, lost time incidents, right? So these people, this person is responsible for the safety of all the people at site, and he has sometimes the power to stop the works at site if he finds something that is unsafe. Now he's also responsible on a great scale. If something goes wrong, this person will be held responsible for that mistake because it would be his short sight that would have caused this on the first place. But then you can always be safe. There are projects with millions and millions of man hours without any incidents because that much effort is put into the safety aspect. The risk part is a lot of risk is handled by this person. Now, why I'm focusing a little bit on this safety engineer is because you see, only if you're an engineer, only if you know the process properly, you can improve the whole process from the safety standpoint. Okay, so this is a very good career option you should actually look into. And of course, the planning engineer, yes, the timekeeper, or let's say the person who controls the time element of the whole project. What are the works to be done, when things are supposed to be completed, and what are the delayed items, when can we complete, what is the remaining time, basically, the watch of the project. Okay, so that should give you a brief idea. Now, after college, you will be starting off as a site engineer. Okay, definitely not a foreman, you'll be starting as a site engineer. And then you have to work your way up. From here you can see a lot of branches. You can become a project engineer or a construction manager, but yeah, you won't directly become a construction manager overnight. It takes some experience too, because as I said, a manager position, because manager position requires a lot of knowledge and skill set. You need to have the entire construction site at your control. So if you compare this to a kingdom, project manager is the king and the construction manager is the general. Okay, and of course I would like to I would like to picture myself as a minister, the planning engineer. Just pun intended. Now these are, next we'll see the triple constraints of the project. Now how to complete a project ideally, and how to bring about the most optimum results. There are a lot of constraints, a lot of, if you list out the constraints, all the 10 items, the 10 knowledge areas shown before are constraints. But the key, the most important things would be, normally people be focusing on time, cost, and quality. And there has to be balance between these three. And this is the sweet spot, the optimum point. Let's say if things are done really fast, okay, it becomes more expensive. If you want to improve the time of the project, you have to put in a lot of resources. You have to go for some expensive processes which you hadn't planned earlier. It becomes really expensive. But if you try to reduce the time, yes, it becomes cheap. But sometimes it goes low on quality. Okay, and quality, if you want to if you want to have high quality, again it becomes expensive. If you want to reduce the cost, yes, quality will be compromised. So there is a balancing point. This area, sweet spot. Okay. Basically, what I'm trying to say is the project manager juggles between these three and has to prioritize each activity so that uh, the project is benefited the most from his decision. Now, in this discussion, we are going to see from the time point of view, because as I said before, when you know what are the things that those are supposed to happen, you're in a better position to control it. Okay. Uh, you see, now I assume that you are in your final year of engineering. Before starting your BTech, you would have been in a very difficult position. Like, you would be really, would have been overwhelmed about the quantum of works that lied ahead, that, that was ahead of you. Okay. Not lied, that lay ahead of you. But then, now that you're completing your BTech, it somehow feels easy. Of course, it's an understatement if I say that it was easy. You'd have gone through a lot of struggles. I personally had gone through a hell lot of struggles just to complete my BTech. So I would definitely understand if you would also have gone through a lot of struggle, yeah, be it personal, be it academic, a lot of financial, a lot of stuff. But then once you finish that process, you understand, okay, how the process should have been, how you could have improved. That comes from an experience. Okay, so knowing how what things are, expecting what to happen gives you an edge on how to control things. That is my point, which is why we are focusing our discussions today on time. Now, I would like to show you a small design phase schedule just to give you uh, a feel of the project. I made a sample schedule just for your understanding. Now, this software is called Primavera, which is what we use here to manage the project. It's just a tool used for project management. It is, basically the skills it really doesn't replace any of your skills required to manage a project. Okay, so first one, okay, this part is called the activity detail window. So this whole thing is called activity window. This, what you see here is uh, the breakdown of the project into different work breakdown structures. I'll explain that later. This you see is a time schedule or time chart or Gantt chart. Okay, and you can see the months being shown here. Now, what happens is when you add an activity, when you add a work package here, there is a time associated to it at which it is supposed to be completed. So
Excuse
that's
me,
how
sir.
you, yep.
Are you? We can only see black background. Are you discussing something else?
I kind of
You
switched
share
the
something. Okay,
I kind of switched the screen, not screen, the window.
but I still see the schedule one design phase Primavera schedule.
Okay, wait, let me do it again.
Okay.
Can you see it now?
Yes, we can see it now. Yeah.
Great. Yeah, so I think I'll have to start again. This is the activity. This is basically how you control a project is. You have some details here. You have a time frame here. Maybe you can see it. See time frame here. Okay, and when you add an activity, you are associating you're booking a time frame to that activity. This activity should happen between this time and this time. And how you can arrive at that conclusion is you list out a lot of activities, understand their interdependencies, and link them together. Maybe you can see these links. Okay, so when you link these things together, it'll give you a chart or a sequence of activities, and the software calculates on itself how the activities are supposed to be linked to each other, and positions the activities with the relative correspondence. What is it? Relative dependencies. So I made a list of activities and linked them together to get you feel about the concept design. Let's say you want to sign a contract today. Okay, and it takes 30 days to develop the concept design. I've linked this after this. It's called a finish to start link. this finishes and this starts. First activity finishes, second activity starts. So second activity starts after the first activity and it takes 30 days. And after that, we have another uh, activity called workshop for concept design with the employer. Now, this has a different kind of link, okay? Because your concept design development is not completed till you discuss it with the employer and get his approval, okay? So what you do, yeah. So what you do is there is a different kind of link that is associated to it that is called finish to finish. When this finish, this should have been finished earlier, or the finish point of this activity is controlled by the finish of this activity. So that's how you link activities together. Now, just to give you a feel, okay, it's a vast topic in itself, but just to give you a feel, this is how you list out the activities, understand their relative positioning and dependencies, link them together, and a chart, a sequence is developed. Okay, and it is red in color because it's in the critical path. We have a straight sequence, a fairly linear program here. It's all in the critical path. Now, critical path discussion is critical path is something which impacts the project duration completely. If you change the duration of one activity in the critical path, the project duration changes. Normally, project duration is controlled by the contract, so you cannot change the project duration. What you'll have to do is, if some activity is delayed here, you will have to mitigate somewhere else. Okay, suppose this instead of this becomes 35. Okay, then the revision you have to take that duration out from this 5 days, so that the end point is the same. This is not how you do it actually at site or in a project, but just to give you a feel, because there's a lot of procedure involved to change even the duration. Okay, so what you see here, I have split the entire project into two stages: stage one design and stage two construction. Now, normally it is the a consultant who develops. Miss, how much time do I left? Do I have left?
Yes, you have half an hour more as per the
Okay.
schedule. Yeah.
Okay. Great. So this, yeah, the stage one design. Stage one design is what, as I said, done by the architects or the designers. Okay. As a planning engineer, what I do is I plan for the activities expected within the stage one design, and I see whether it is as per the contract between the consultant and the employer. Because within the contract, they were the time frame would have been mentioned. So I tried to discuss with the team to control this. Okay, that is first the concept design, then the final design, and then it goes for tendering. After tendering, after the end of tendering is marked by the completion of the first phase, or normally we mention it as pre-contracts phase, where the contract is awarded to the contractor, the construction contractor, and then the stage two starts the construction. This is typical of an AEC industry project, but sometimes even in AEC industry, we have turnkey projects where the complete engineering design, the design is done by the contractor. It is called design and build contracts. Now we'll leave that to a different topic. We'll leave that discussion to a different session. So construction, I have just mentioned a duration of 515 days because it is the contractor's responsibility to come up with the detailed list of activities that comprises of this duration. Okay, so this will be the contract between the engineer and designer and the client. Now I'll switch back to the PowerPoint. Can you see the PowerPoint?
Not yet.
Now,
Yes, it's loading. Yes. Okay.
So that was basic feel of the design phase. Okay. Now, as I mentioned earlier, there's a separate schedule that will be provided by the contractor. Okay. Now, you see, maybe you'd have noticed I switch between being the contractor and the consultant. The problem is I'm working as a consultant right now, so most of the time I tend to speak from the consultant point of view. But no worries, I'll try to keep that in mind. Now, the schedule to be provided by the contractor, there are basically two types. First, the tender schedule during the tendering stage, before the contract is awarded, the contractor, uh, offers to complete the project within a stipulated time, okay, as required by the client. And if there are some negotiations happening, that'll happen at that point, because once the contract is finalized, the contractor has to construct within that stipulated time. Okay. Now the time I've taken here is for the project is 16 months. Okay. So basically 515 days. So the contractor has to construct the entire structure of the building and hand it over within that 515 days. He has now, but this tender schedule, at the tender stage, the discussion goes on whether to finish it within 515 or should we extend it, should we reduce it. But normally it doesn't, that discussion doesn't happen to reduce. It all only happens to extend the duration. But once the contract is signed, the contractor submits a planning package where he has a clause 14 program. A clause 14 program is what clause 14 refers to the FIDIC contract, FIDIC 1987 contract forms, okay, where the contractor uh, promises to complete the project within the stipulated time, and he lists out the activities of his plan of execution of the works. Now there'll be an S curve involved, which you'll see later. These are the bare minimum requirements of a planning package. There are still more reporting requirements, the details that is submitted, but I will not get into that. Bare minimum requirements of a planning package. Now, planning package is important because once a planning package is approved, the time of the contractor, the timings of the activities are measured based on this planning package. Okay, so the contractor promises to complete the the foundations by this date, the roof slab by this date, the first floor slab by this date. The contractor promises to start the installations, MEP installations by a particular date. All these dates, as you saw earlier, will be listed out when you program the activities, when you prepare a program in the Primavera. You will, but by the way, Primavera is just one of the different softwares used. There are many other softwares, but as I said, that's the one which we use here normally. So when you use a project planning software, you'll get a list of activities, and dates will be assigned based on the dependencies. So then you can hold that contractor responsible to that activity and that time frame and that durations and that dates. So the contractor has to provide that early on before he starts with the construction. Now I'll show you an S curve just to get a feel of how the project progresses. Now S curve is very important as from the project point of view, because this shows the rate at which the progress is expected of a project. The orange color represents the progress values, and the gray color represents the cost values or invoicing values or cash flow. Okay. Now this is how the progress is supposed to happen. Ideally, there's a triangle where the 25% of the project completes within the 35%, 33.3% of time. Next 50% of the project completes within next 33% of time, and the final 25% of the project completes within the 33.3% of the time, remaining 33.3% of the time. So that is a standard S curve. And if you look at it, you can see the project progress is a very decent one. But if there are spikes somewhere here, then that shows that there is some mistake with the schedule, or there is some anomaly that was not expected. So basically, you use it with project progress values. Okay, and then finally, then there's a cash flow. Now, cash flow is important from the client point of view, because a client requires to know what will be the funding requirements of the project. Now, as per FIDIC 1999, you have to have a client who, I mean, the client has to have a funding plan for the project. If the client doesn't find funding halfway through the project, it is the client's mistake, and if any delay happens to the project, the client will be held responsible. Okay, so to arrange the funding, because it's not like the client will have the money ready in their bank accounts. The client will have to source the funding from investors, from banks, etc. So this shows how much funding is required, because this is based on the progress, and the progress directly converts to the amount of work done, and amount of work done translates to cost. What cost will be invoiced at that point of time. So this is an S curve that is prepared, and you can see the monthly distribution of progress values, cost values. There's a defects liability period, which we'll discuss later. Now, extension of time claims is also very important from the project point of view, because you see, this is where things, you start to analyze when things go wrong. See, suppose there are delays from the contractor side or the employer side. Now, how do you accommodate those delays into the project? If the contractor is at fault, what are the things to be done? If the employees that are at fault or engineers at fault, what are the things to be done? These are the aspects of, if suppose the contractor is at fault, the engineer raises a claim against the contractor saying that the project is delayed because of your mistake. You will be penalized at the end of the project, or at the time of completion. We will deduct this much amount from your bank security, okay, or this much amount will be deducted from your progress payments. So because it's contractor's mistake and the employer is losing see, let's say this project is for 16 months, and the employer is expecting a lot of expecting to start the hospital after 16 months. So an employer has taken loans to come to start this project. If after the completion of 16 months the project is not completed, employer has a lot of damages. Now this damage employer can claim from the contractor, but of course those terms will be defined in the contract. Right. Now the contractor, on the other hand, finds some problems from the employee, because if some approvals, some clearances are not provided by the employer, and the contractor cannot work at site in any means possible, contractor raises a claim against employer. So what happens is, from the time point of view, extension of time has to be given so that the contractor is not penalized. Okay. Then variations. While executing the project, there could be some factors contributing to changes within the project that was not accommodated earlier before signing the contract. That is meant by variations. Now, what happens is, because of variations, also a lot of time changes, time calculation changes. Then extension of time claims. This is a different area altogether. Forensic delay analysis. Forensic delay analysis happens when you see, you are probably familiar with the term forensic. There's even a Malayalam movie called Forensic. You might have seen it, and maybe you're aware of the term forensic analyst, forensic experts. Now, what do forensic analyst or forensic expert do in real life? You see, normally a forensic analyst examines the dead body of a person just to understand what was the cause of death. Should someone be held responsible? Okay. Here in the project perspective, forensic delay analysis is done by a forensic delay analyst who is trying to find the fault, whose fault it is, because contractor will always try to hide his fault, the employer will always try to hide his fault. So because of whom is the project being delayed? That is what a forensic delay analyst do. And I tell you, my real job here, I'm also a forensic delay analyst. I do forensic delay analysis because without this forensic delay analysis, it is impossible to calculate the variations and EOT claims. Basically, the extension of time claim. The dead body here is the project schedule. You have to just remember that in mind. Okay. Now, you saw a lot of stuff about project management, but how does this benefit you? You see, you have to understand there is all these 10 knowledge areas contribute to the smartness perspective. Okay. Now you have You're just being smart on how to complete the project as per the requirements. And if you study that 10 knowledge areas properly, you'll get the knowledge to start with stuff and to execute things. But basically, as I said before, you need to have a kind of PhD in smartness. That's how you control everything, because every day you'll be facing a lot of problems. But as a student, how does it benefit you? You know, when you study about integration management, you get a grasp about how things happen in life, in a project, in your academics. Let me tell you, you have a curriculum, curriculum where your entire BTech degree is divided into modules. When I was studying, it was 4 modules per semester. Now, within 4 modules, you have chapters. Within chapters, you have topics. Within topics, you have data. So if you prepare a whole list of items just like that as a work breakdown structure, you see, or if you take a textbook and just you start asking yourself, what does each chapter mean? What does a topic in a chapter mean? If you try to understand that, you'll get a better understanding of the topic, and you'll get an overall view of the topic, and it makes your life very easy, because the data retention is far better because you have a structured item. And that is what basically a planner does. Planner brings about the whole structure. um, you know a planner tries to find a structure between all the complete chaos. Okay, so this chaos is the data and information floating all around. But when you have a structured approach to things, you are able to finish things properly, conveniently, and most importantly, you don't miss out on any aspect. Okay, time, the work breakdown structure, as I mentioned, your time management skills improve when you have complete work breakdown structure. And rolling wave planning is a very beautiful concept, which I would like you to understand. Rolling, suppose you're going on an excursion, okay, a trip, a 10-day trip. You can either plan for everything right from the start, but then you will be focused on only completing your targets. But when you're going on a trip, what you do is, suppose you're going from here to Ooty, and then from Ooty, and not here, I first say from your place, for sure, to Ooty, and from Ooty to, you're planning to go to Bangalore. You go into Ooty, and then after reaching Ooty, you're adapting to a situation there, and then at that point you decide what are the fun activities there. You ask the people around, and then you plan for things there, and then you execute it. After finishing Ooty, then you go Bangalore. It's like, flow of a wave. You build up a wave, and then it falls down, and then the next wave takes over. That way you can reduce a lot of pressure on yourself. Okay, because when you have listed out everything together, and things don't go as per the plan, that could actually have more demerits, or that could have a detrimental effect on your morale. Okay, and then we have this time assessment. Yeah, when you do time windows, when you assign time windows for your activities, let's say you're studying a subject. Basically, when you prepare for your examination, you have 4 modules. You break it down to chapters, topics. You plan that, okay, if I finish this chapter within half a day, then okay, I'll be able to complete the rest of the topics. If I take more than half a day, I won't be able to complete the rest of the topic. That is actually a time calculation which you are trained. Okay, during the course of your BTech degree, you have been trained to do that without actually telling you. So that is the engineering skill set which you're learning without actual training. That is something what should be made visible to the students there, because you learn to plan your time to complete your exams, to learn to study and to prepare and to give the exams. And then cost factor. Now, cost factor, it comes into play in a different aspect altogether. See, to be the most important person of a project or team or a company, you need to know what is happening cost-wise, because everything is run by the cost. So the commercial implications of your activities, of your actions, if you don't know how is it going to affect the project and company cost-wise, you're at big loss. So start asking yourself, how do I, let's say if you see a building, how much time would have it taken to construct that building, and how much would have that building cost? So from that, then the next step will be to inquire to people around to check if your assessment is right. And then when you go ahead little by little, you understand the details of the project without even you knowing, when you're just hunting down the cost factor. Okay, so be be very keen on the cost element of everything. And procurement wise, yeah, contracts management, which we'll see soon. Risk management, this is one approach which I would like to you to understand. You see, normally from your expectations or from your experience as a student, I can tell you, if you're planning for an exam, we normally plan for things like you just prepare a time scale like half an hour for this, 1 hour for this, 2 hours for this. But as a student, you never normally think, what if I don't complete it? How do I manage things later on if things doesn't happen this way? Okay. Now, when you are at that level of thinking, then I should tell you that if you are a person who thinks that way, then normally you won't get any back papers, because you are assessing the risk factor of preparation itself. Okay, even in project, you have a beautiful schedule, and you don't just start working on it from day one.